Hi guys, how are you? Welcome back to our Calculus 1 classes. Last time I discussed how to find from the graph of the function or the graph of the first derivative, the increasing, decreasing, critical point, all these things. If you don't mind, go back to the first class before you start this class, the first video, which is part 1. Don't forget to, if you have any question, to text me or email me for any topic you need help with. I will be more than happy to help you. Now our class, again, the second part of this topic. Like, subscribe is important. Please subscribe and like us. Okay, let us go to our class. Last time, what we discussed last time, guys? We discussed? Yes. What we discussed? We discussed the graph. Today we're going to do how the steps to find the above concept of the critical point, increasing, decreasing interval from the function. Now, too many, it's the steps, I wrote it like this to organize you at the beginning, but with the time, when you are familiar, you will be okay to do it. Find the first derivative, f prime of x or y prime or dy by dx. This is the first step, and you should be familiar with this. After this, you finish already how to find the derivative. After that, you make the derivative equal to 0 to find something we call a roots or zeroth of the first derivative. Draw the root in the number line. Between the roots and to the left, right side of the root, choose a test value, any values you want. Any values will work. Plug these values in the first derivative. Okay, then, okay, good. You see that? If the sign is positive, increasing, if the sign is negative, decreasing. The root of the first derivative is our extreme and maximum values or a critical point. To find the values of this, you plug them back in the main function. Okay, this is my example. For the function below, find the critical point, increasing and decreasing interval, extreme and maximum, and minimum point. This is my function, 2x cubed plus 3x squared. To save your time, I found the derivative. What the derivative? 2 times 3, 6. 3 minus 1 is 2. 2 times 3, 6. X minus 12. Now, after that, what's the second step here? To make it equal to 0. You make this guy equal to 0. 6x squared. I changed the 6 and 12 to be black to be able to take it as GCF. Then 6, and 12. We took 6 out. What left inside? X squared plus x minus 2. Now this, when you factor it, this becomes what? X, not x squared. Exactly. Now remember, if we have no number here, the number is what? 1. Right? There you go. That will help me in factoring. I need 2 numbers. If I multiply them, negative 2. If I add them, plus 1. Plus 1. Negative 2. Multiply to negative 2, add up to 1. These 2 numbers are easy. These 2 numbers are what? Easy. X squared plus 1. This x. Oh, I'm sorry. This is my function. Okay, this is my function. Exactly. Then the factoring, x and x. 2 number multiply to negative 2, which is 2 and negative 1. And they add up to 1. Plus 2. Minus 1 give you what? Plus 1. Good? Now we have the factors of this derivative. Then make x equal negative 2 and x equal what? 1. Okay. I'm going to move to the other board to find the increasing, decreasing, and the max. So let me just try to copy this and see if I can paste it in the other board. You guys who remember? I can't see it. Okay, let me just carry it. Yeah, and see the function. I remember it. X squared f prime of x f prime of x equal, we did 6 in black, I'm gonna do the same, and x squared, right? And here plus 1x minus 2, right? Plus 1x plus 2 minus 2. Then we factor it. We factor this, we make this one guy equal to 0. X squared plus x minus 2 equal to 0. Then we have these two factors, x and x, plus 2, minus 2 plus 1, right? Minus 2 plus 1, right? Or plus 2 minus 1, right? Plus 2 minus 1. Minus 1. And this equal to 0. From this, x equal to negative 2 and x equal to 1. Good. Then x2, then we have two values. We have to deal with these two values, what we said in the number line. Then this is my critical point CP, I'm writing here, CP equal, use this type of parentheses, 1 and negative 2 and 1. Now I have to draw this in the number line. In the number line, I have my number line here. I have two values, negative 2, make space, negative 2 and 1. Now the step after that to choose 3 test points. One in the middle, one to the right, one to the left. Let me just move all this guy down. Okay. Okay. Choose easy values. Don't choose, look here, I'm going to take here negative 3, in small handwriting, negative 3, in the middle 0, any value, and here 2. Then after that you plug each value in the function, in the derivative, in here. To see what's the answer, negative or positive. Start with the 6, 6, negative 3 squared, plus negative 3 minus 2. If you solve this use calculator, it's going to be positive. Then everything here will positive. Then I don't need it. I'm going to erase it at the end. I'm going to leave it for 1 second. Then I will touch it after that. I'm going to erase everything there. Now try with the 2. Plug the 2, 6, 2 squared. Notice something. You see when I have negative, I put the negative in parentheses. Please always remember this. 2 and here 1 times 2 minus 2. This cancel. 4. Look here. I don't care what's my answer. I care if my answer is positive or negative. Now the last one, which is the 0. Plug the 0 there. 6. 0 squared. 0 minus 2. 6 times negative 2 is negative. Alright. 1 minute for you just to see what I did. Just okay. I will not talk. I'm going to leave it for you for 1 minute and see what you are going to see. Okay, that's good. I'm going to erase the top one, all the test point. The negative 3, 0 and 2. I'm going to erase it. Negative 3 and 2 and 0. I'm going to erase it now. 1, 2, 3. Erase. Yes. Because I need to write make it nice and neat. You see, I used it, then I delete it. I don't need it. Okay. The function, look here. Increasing, going up. I said, right? Up to the negative 1. And I like my student to draw a vertical line here at negative 2, at 1. Vertical line. I like them to do vertical line. Let me just make it vertical. And it just like this. and move it here, and the same thing here. Just to stop at this vertical line. It's not bad to have it at good. Then this guy keep increasing up to here, going up, then going where? Down from -2 to where? Going down to the 1. Then at 1 he back to increase. Because this is green, I'm going to make this line a green. And a little bit bold. And this line green. A little bit bold. And this line blue. And a little bit bold. Now this going up, I'm going to use my this going down, which is decreasing, and this graph will help me to find the maximum and the minimum. And this going where? Up and up, up. Okay, then increasing. Where increasing, guy? From -infinity to where? -2, comma, 1 and infinity. But I don't like comma. I like to use what? Union. Some books they want comma, but you can use comma or what? Union. Decreasing in the middle. You see? Decreasing from -2 to the 1. Good. If I'm able to graph this way, my problem is over. Done. Look here, at -2, back the graph, at -2 here, at x equal -2 maximum, at x equal 1 is minimum, right? Then at x equal -2, at x equal -2 maximum, which is -2 and f of -2. f of -2 is the value of the maximum. The value of the maximum. The value of the maximum. -2 and f of -2. All what you have to do, take -2 to the function, not the derivative, and plug it in the function. Now, f of -2 is maximum, right? f of 1 is what? F at x equal 1 minimum. f of 1 is the minimum value. You plug it where? In the function. 1 f of 1. You go to the function and you plug it. That's all what we have. Let me just show you the graph of this function. The graph of this function. And then all what I did after I found the derivative, I solved the derivative to 0, find the two roots, the zeros, plug them in the number line, choose test values here and there and here, plug these test values in the derivative. Back just a few minutes in the video, you'll see it. Then increasing from -infinity to -2 and 1 and, not and, comma, or. Don't use and. -infinity, -2, or 1 to infinity, or. Or mean what? This guy. Or mean this guys. Okay, good. Then this here maximum at x equal -2, the value of the maximum f of -2, minimum at x equal 1, the value of the minimum f of 1. Good. F of 1. Good job. Good job? Yes, good job. Let us back to our board and see what we have. Okay. Then we're done with this problem after we find, okay, the derivative, we done from here. Okay, you see the steps I did? Find the root. Since you find the root and the zeros, you're good to go to the number line, its critical values. And we choose this, we did it in the other board. Now let us take our function, which is this function, 2x cubed, 3x squared. I can't remember, yes, let me see. 2x cubed, 2. Remember, x cubed minus 3x squared plus 12x, I think. Minus 12x plus 5. Minus 12x plus 5. Minus 12x plus 5. And minimize it a little bit. Okay, and take this back. You see the maximum we found? -1, right? At -1. What I did? Minus 12 minus 2 x equal -2. What I did, plus 3x squared. This is plus. This is plus, yes. Now, okay. This is plus. Maximum at -2. You see? And let me just oh. Just to see the whole graph. We said, look here, this point is what? -2. Right? Then from -infinity, and this point, okay, just I'm gonna keep it like this. Okay.